These are the notes for the 5.2 extension lesson, graphing proportional relationships. So we've talked about proportions in lesson 5.2. Now we have them as graphs. We've seen them in tables like this. We can take those tables, write them as ordered pairs, and then graph them on a coordinate plane with a y and an x axis. A couple of things. Remember, you can graph them from a ratio table, as shown down here. The ratio table shows a constant rate of change. That means your line is not jagged edge like that. It's a straight line. The constant rate of change will show the graph passes through the origin. The graph of every proportional relationship will pass through the line of origin. So the origin is right there at 0, 0. That's where the line of that's the origin, 0, 0. So in order for there to be a proportional relationship, the line, whatever line is drawn, must cross through the origin. So it must be straight. Okay, by straight, not curved, not jagged edges like that, and it has to cross through the origin. So if I drew this line in here like that, it's a straight line. However, it's crossing through at 5 on the y-axis instead of down here at 0, so it is not a proportional relationship. So it's got to meet those two criteria, straight line and crossing through the origin. Use the graph to determine whether x and y are in a proportional relationship. So remember, ordered pairs are always x comma y. The x value first, y value second. So we're going to write these from our ratio table. We're going to write them out as ordered pairs. So we have 2, 6. We have 4, 8. And we have 6, 10. And then we're going to graph all three of those. So again, it's marked. You got your x values and your y values, and the x values are always first. So 2, 6, we go to 2 on the x and 6 on the y. We put a dot right there. Next one, 4, 8, we go to 4 on the x and we go to 8 on the y, and we put a dot right there. And then 6, 10. We go to the 6 on the x and 10 on the y and put a dot right there. And then we would connect all three of those dots on our paper using a straight edge. And we can see we do have a straight line, so it meets one of the two criteria. However, here's the origin down there, so it does not cross through the origin, so our answer is no. Those ordered pairs do not form a proportional relationship. So a couple of things in your notes here. If the graph of the line does not pass through the origin, then it is not in a proportional relationship. If the graph of the line does pass through the origin, then it is in a proportional relationship. And then, so just some things, I want you to be able to read the graph and interpret what's going on there. So it says the graph shows the distance traveled by the Mars rover Curiosity is a proportional to the time traveled. Interpret each plotted point in the graph. So we have 3 plotted points, the 0, 0, the 1, 1.5, and the 3, 4.5. So it's already done for us over there. 0, 0 means the rover is traveling 0 inches in 0 seconds, essentially that it is stopped. 1, 1.5 means the rover travels 1.5 inches in 1 second. Again, notice how it's kind of backwards. In our ordered pair, we have 1, 1.5, but the 1.5 is mentioned first. Okay, so time generally is going to be mentioned second. And when we write, so we also have our rates, and we can make that as a unit rate. So we can say that the rover is traveling 1.5 inches per second. And one more ordered pair, the 3, 4.5. So we can say the rover travels 4.5 inches in 3 seconds. Because the relationship is proportional, you can also use that point to find the unit rate. So the 4.5 inches over 3 seconds, we would divide them both by 3 to get the denominator to be 1, and we would still get the 1.5 inches per second. Again, that works because it's a proportional relationship. And We know it's a proportional relationship because in the graph it's a straight line and the line crosses through the origin. So every ordered pair will always simplify to 1.5 over 1, every single ordered pair. Of course, except for the 0, 0, but we need that 0, 0 to start. Now it's things that you will try here. So again, it says interpret the graph and find the unit rate. Remember, the unit rate is when the denominator is 1. And remember, it's always the y values on top and the x values go on the bottom. And remember, with an ordered pair, it's always x comma y. So when they give you these ordered pairs over there, the x is first and the y is second. But when you're trying to find unit rate, you make sure that you put the x on the bottom and the y on top. So just like they did in this problem here, they talked about the 0, 0, the 1 comma 1.5, and the 3 comma 4.5. That you're going to do that with those three ordered pairs. Use words, labeling, what does each one of those represent, and then also make sure that you list the unit rate. Here again, tell whether the x and y are proportional. So again, make sure that you write out the ordered pairs. X always comes first, y always comes second, and then do your graphing, and then answer that question, do they form a proportion? If the line crosses through the origin and it's a straight line, then your answer is yes. If it doesn't have one of those two criteria, then your answer would be no. Also with that one, the graph of a proportional relationship passes through 12 comma 16 and 1 comma y. It's asking you to find y. I'll give you a hint on that. Want to set it up as a proportion. And again, we like to have the y's on top, so 16 over 12, and we want to know is that equal to y over 1. So to solve this, just do your cross products. So 12 times y has to equal 16 times 1. And then your exit question, what will the line on the graph pass through if its number set has a proportional relationship? And I reinforce that over and over in these notes, so you should know the answer to that question. So finish up these questions for homework and bring it to class with you.